So let's end this examination of what is psychological research methods, scientific psychology, and psychology's focus on science with scientific integrity. Um, and I want to make it clear that the purpose of this class is to really look at the methodology and systems, if you will, of how do we learn about human behavior. What are the experiments and how are the experiments conducted that allowed us to understand social psychology, cognitive psychology, developmental psychology, and the various therapies and interventions that we use in psychology. But part of that also has to be an understanding that we are talking about research of human behavior, and by de facto, we're researching humans. And scientific integrity has two major parts: the integrity of the actual studies themselves and the ethical constraints and ethical requirements of doing scientific research on humans and human behavior. So that really becomes the big question of what is scientific integrity, and scientific integrity is both. Scientific integrity is the ethics of how we treat our participants, the ethics of how we design our studies in relation to the human participation, and also how we conduct ourselves as scientific researchers. So the first part of scientific integrity is how we proceed as actual researchers. And this is also a recognition that people are people. There are external pressures on their behaviors. And specifically within the world of research and science, your fame, your career, your success, your monetary success is often tied on whether or not your theories are provable, and also whether your theories are then used by other researchers and within practical application. In my own field of industrial organizational psychology, the way you make it big is not only do you create a theory of how behavior of humans function in the workplace, if you can then market that as something that organizations will pay for, that's where you move from being a decently paid academic to a very successful person. So recognizing that means that there are pressures on people to maybe be less high in their integrity. So misconduct in research and scholarly activities does occur. And it occurs at basically three main levels that we need to be aware of. The first one is fabrication, second one is falsification, and the third one is plagiarism. So fabrication is basically simply creating data. We actually are going to fabricate data as a part of this class. And that is because we are never going to present any of the data that we get from this class as if it was a true experiment. And I want to make that very, very clear, that the experiments that you're going to do as groups in this class and the papers you're going to write are for this class only. They are not, they are a, if you will, a scenario of scientific research. They are a sample, they're a work sample of scientific research. They are not to be presented anywhere. We are not gathering real data. But if you actually do fabrication and then present it as if it is real data, publish it, promote it, go to conferences and talk about it, that is a major breach of scientific integrity. And this has occurred. There have been examples where there has been, in hindsight, major studies that have been found to be completely fabricated. Now, often, the people doing this fabrication are fairly well versed through the lit review of what is a believable fabrication. And that the way they're found out often is either someone, basically, there's a whistleblower who says, hey, we never conducted this study, or B, continued research starts to have problems finding their results again. So remember, I said psychology and science in general tends to be a replicative process. Once results come out, people try to test them in new situations with new people. And if a particular study seems to have a very astounding set of findings and no one else is able to replicate those findings, that starts to call into question that original study. And that's one of the other ways fabrication has been found. The next one is falsification. In some ways, this is lesser, but in some ways can be even worse. Falsification means that you did conduct the study, you did find some results, but the way you found them or the process you had to go with, you conceal. You falsify some of the methodology. You leave out a couple of steps that you did to get the results that you had, and those are important steps. A good example of falsification would be claiming a direct causal relationship between two variables when you know for a fact there actually is another explanation because you measured it, but you didn't include it in your paper because it weakened your paper. That would be an example of falsification. It's basically kind of lying with statistics. You did find something, but the way you found it and the process you went through, you're concealing. That's falsification. And finally, plagiarism. And we're going to talk more about plagiarism in lab and within this class, but plagiarism is ever presenting anyone's work as if it is yours. And plagiarism can be a very easy thing to accidentally do, and a lot of people have, quote unquote, accidentally done plagiarism. Now, whether it's truly an accident or not is hard to tell, because accidents versus intention, well, that's whether or not they intended to do it. And how do we know whether someone intended to do something or not? However, just be very careful whenever you're actually talking about anyone else's research. Just make sure you cite it. Make sure that it's clear that it is not studies that you've done, it's studies that you are citing. Also be aware that if it comes down to actually publicated works, you can plagiarize yourself. So if I publish an article and then I lift an entire paragraph from that article for another article, well, not only am I self-plagiarizing, whoever published that first article owns the rights now, if you will, to that initial paragraph that I'm now using somewhere else for some other publication. So don't worry too much about self-plagiarism as a student. Self-plagiarism comes into effect if you start actually getting publications or conference presentations. That's when you need to make sure that everything you write is not only not taking from other people, but if you do take from your previous work, you need to cite that as well, because you can effectively self-plagiarize. So misconduct in research and scholarly activities does not include honest error or different opinions. It includes purposeful falsification, personal falsification, or to some degree, personal plagiarism. However, generally speaking, if you look at the Code of Ethics of the APA, which is the major association, so the Association of Psychological Science, that's APS, and APA, the American Psychological Association. Both of their ethical codes basically have a hard line against plagiarism, as does the Code of Conduct of SIUE. So be very careful to never copy someone else's work or present someone else's research as if it is your own. And one of the ways that we try to get around scientific integrity is both through the internal review board that looks at research. So in other words, to do some research, you need to submit that research for a review before it ever conducts, but also through the actual process of replication, people doing your study as well and looking for these issues. As far as the internal review board is also how we move on to our second part of scientific integrity, which is the ethical integrity of the study itself. So if we talk about ethics, let's talk a little bit about the historical context. And basically, whenever we look at the history of any field or any country or any culture, we probably start to find things that from a modern light we're not very proud of, and psychology is no different. So when we look at the past of ethical experimentation in humans, up until pretty much World War II, there really was no ethical constraints on how you actually conducted experiments. The Watson study in 1920 is often used as an example of this, and this is basically a study where one of the proto-behavioral psychologists, Watson, was studying infants, and he was basically seeing if he could classically condition fear of white furry objects in various infants. Now again, think about this. We're talking about an experiment where you're taking orphans who have no right to either refuse or accept whether or not an experiment is being done to them, and then you're trying to manipulate them experimentally to fear an object for the rest of their lives. By modern eyes, this seems fairly monstrous. But it was also one of the core initial studies that looked at kind of behavioralism in understanding human behavior. The Monster study in 1939 was actually a study of speech pathology, again using orphans, where they tried to either reduce stuttering or induce stuttering in orphans. Now, this study, again, even at the time it was done, it was very quickly dubbed the Monster study because even without ethical review boards, a lot of people had problems with how this study was done. But also a lot of information on speech pathology came out of these studies. The German experimentation, obviously, during World War II resulted in the Nuremberg Code, which was basically an international code supported by the League of Nations and then, of course, the United Nations that basically states what you can and cannot do in experimentation with humans. Even past that, though, we start to see that as we move forward, ethical concerns can still come up even after having a strong set of ethical codes that we need to follow. I often refer to the Sharif studies in 1961, which is actually one of the major studies of social psychology, especially looking at intergroup conflict and prejudice. Basically, if you're not familiar, Omar Sharif did a study where he basically used a kids' summer camp, and he induced in-group and out-group conflict. He then created two separate groups that disliked each other intensely, and then he tried various interventions to get rid of that dislike. In other words, he induced prejudice where it should not have been initially, and then he tried different methods to remove that prejudice. Again, looking back at it with a modern eye, it sounds fairly monstrous to take a bunch of grade school children and induce prejudice in them. And then some of the methods he used to try to remove that prejudice included fairly strenuous physical activities that they had to do together, which could have technically been dangerous. For example, one of them was all the kids had to drag a large storage or a cargo truck that was stuck out of being in a stuck position. So again, for modern eyes, that would probably be a study that would have a problem getting through a modern internal review board. And I'm going to end with the heart disease research. The initial studies looking at the effects of mild doses of aspirin on heart disease, the initial study found such a strong effect that this was actually saving people's lives that the study itself was called off in order to start giving everyone the doses of aspirin. In other words, what they found was they were experimentally testing whether or not small doses of aspirin reduce the chance of dying from heart disease or a heart attack. The people in the experimental condition that were getting the small doses of aspirin were surviving at such a large rate, the experimenters realized the people we're not giving this to are dying in our study. We don't feel comfortable with that, and they started giving it to everyone. So ethics are not always a black and white question. It's an ongoing question through any study that has to be examined and has to be asked, are we behaving ethically and are we behaving in a way that will stand up to the light of examination? So ethics or ethical systems are designed to prevent people from being used as scientific guinea pigs. So when we talk about scientific integrity and ethics, what we're talking about is an ethical system or code that we've designed to try to make sure that people are never in a situation where they are basically rightless. They are guinea pigs, if you will, in a scientific experiment. The contemporary emphasis is on the rights of people to take risks to save themselves and the focus of the right. In other words, we don't want to have such a strenuous system that someone that is, for example, suffering from a terminal disease cannot participate in a study that might risk to save themselves, but they should be well informed and they should be making the choice themselves. Individual people have the right to choose whether or not to be in a study, and if properly informed, have the right to decide whether they agree with the risks or not. So basically, it comes down to the question, is it ethical to experiment on people? And the general answer that most cultures have come up with is that it is, with some caveats. So can we withhold treatment from people? And what that means is if we're testing, truly putting it to the test whether or not a drug or an intervention can save lives, we pretty much have to give it to some people and not others. So is random assignment ethical? And some people would argue that in some situations it's not, that we should be looking at need. And there are other statistical methods we can use to examine that. So for example, if we were truly wanting to test a drug, for instance, on its treatment of a terminal disease, we may decide that we would give that drug to the people that are at most risk for the disease, while not giving it to people that are at lesser risk, and then looking for the difference, understanding there's a difference between those two groups to begin with. We also need to recognize that we may need to discontinue an experiment for ethical reasons. So for example, if we find this new drug is having a phenomenal effect keeping people from dying, for example, low doses of aspirin, we may decide to call off the experiment to start actually giving everyone that treatment. We also want to make sure that whenever possible, people have at minimum confidentiality. In other words, their records will not be shared. And at best, autonomy. In other words, there's no way to identify whether or not they were in the study and to never connect their data to them as an individual. So let's talk about internal review boards and kind of the modern requirements for scientific study of human behavior and study on humans. So the Federal Judiciary Center Advisory Council on Experiments basically says that you can conduct experiments on people when There is present conditions that need improvement. And that's a pretty easy bar to pass. You're basically saying your experiment has to have some practical application. It has to be applying to something. And that could even be just a basic understanding of human behavior, but you have to be able to justify why are you doing the study. You can't do a frivolous study that has no practical application, or the data could not result to further studies that have practical application. The experiment itself needs to provide the necessary data. So once you say this is why I'm doing the study, you need to be able to defend that the methodology you've chosen will actually be able to address that question. And again, this kind of gets the idea of just frivolous experimentation for experiment's sake. The results of the experiment need to change policy, and the rights of the individual are protected. Now again, these are not necessarily mutually exclusive. So if you've presented that there are conditions that need improved, if you've shown your experiment will provide necessary data for further use, if you can show your experiment may change policy or create a new intervention, all of those are good reasons. However, in all of these cases, the rights of the individual have to be protected. And again, those rights we're going to go over in the next couple of slides, but those rights basically come down to the right of the individual to make an informed choice of whether they want to participate or not participate in the experiment. So let's talk about protecting those participant rights. The first one is voluntary participation, and that's a little bit harder than it sounds to begin with. When we talk about voluntary participation, we also have to really ask, are we giving the person enough information that they can make a voluntary decision? And are we making sure that they really do have a choice? Let me give you an example of how we might have a situation that seems like it's voluntary participation, but it may not be. So you actually are doing an experiment, and you're doing it on a prison population. You're giving them all the information they need about the experiment. But as an incentive to the experiment, anyone that participates gets 2 years off their sentence. Do you think a lot of people who probably normally would not have done your study are suddenly going to be willing to do your study to get 2 years of their life back outside of prison? Probably. They probably are no longer voluntary. Yes, they're still getting to make a choice. Yes, they could still say no, but you've set up a situation where it'd be very hard for them to say no unless they are absolutely opposed. In other words, you're going to get people that normally would have said no saying yes. And that's pretty much the bar you want to ask. Am I providing? It's okay to provide some compensation for someone, but the compensation should be fair for the time that they're doing. So for example, if your prisoners normally would make $2 an hour working at the prison and your experiment takes an hour, then you could pay them $2. That would be acceptable. Then they can make the choice. Do I want to exchange the time I normally would for regular work for this instead? But if you're offering them a large amount of money or time off their prison sentence, you're probably getting to an area where most people would say yes, even if they didn't want to do it. The next one's autonomy. And basically, when we can do this, we should. And this means that once the person is done with the experiment and we have their data, there is no way to ever connect that data back to the person. The data does not have their name. It does not have an identification number. There is nothing to connect the person that unless I saw the person doing the study and set over them and made some marks that I shouldn't make on their materials, there would be no way to ever tell, once everyone turns their materials in, who was who. Now, I would still know that it came from an individual. I would have this individual provided me the following data, but I wouldn't know who that individual is. When we can do this, we should do it. Now, sometimes we can't. For instance, I might be giving a personality measure at the start of the semester, and 3 weeks into the semester, I might have you coming in to do a task in my lab. I need to connect your personality data to your performance in my lab. Therefore, I would have to either gather your name or an identification number. That means that you're confidential. I am promising you as an ethical scientific researcher that I will not share your information. I will not let people look up your data, but it is not anonymous. There is a method that could be used to draw that data back to you if it was made available. Now, when we're doing confidentiality, it also usually is to our benefit to make it very hard for someone to force us to let people know. So a lot of times we might actually quickly have people create code numbers, which we don't necessarily have a direct connection to them. So for example, we might tell them, use the last 2 digits of your social security number and the last 2 digits of your birthday to create a code that you'll use when you're doing your personality data, and 3 months later you're going to use that same method to create a code when you're in the lab. And therefore, I don't ever actually have your name attached to the data. I might use your SIU ID number. In that case, though, as soon as I've actually connected the data, I would want to remove or delete the files that have those identifiers on them, or keep it in a separate file for later to where the two are separated from each other. We want to take steps to make sure that if we're offering confidentiality, we're telling the person, yes, I could connect the data to you, but I'm not going to, and I'm not going to let anyone else do it, that we have taken the steps to make sure that happens. We also need to provide participants with a right to service. What a right to service means that if we are doing anything that might change their mood, change their perception of the world, or upset them, that as a part of it, we let them know, one, this may happen as a part of the study, and two, here are services that are available to you if you need to. So for example, if I was inducing a phobia in participants, if I was looking at people that have a fear of snakes, and as a part of my study, I'm going to expose them to some snakes, one, I would have to let them know so they can make a voluntary choice whether to participate in that study. And then I might also want to provide access to services of counseling with a phobia counselor after the study if the study affected them negatively. Now notice that the more that you need a right to service, the harder it's going to be for you to convince an outside panel that your study truly needs to be done. In other words, it's going to become more of an ethical concern. That doesn't mean that it can't be done. It means that it is going to be more of something that's going to be carefully checked to make sure there's a reason this study is being conducted. So a part of protecting the participants is giving them informed consent. So informed consent, basically, it's often referred to as an informed consent form. It basically is a form that tells them what is the study, broadly speaking, what can they expect to anticipate or participate in, what are the dangers of that study, what are the advantages of that study, to allow them to decide if they want to consent or not to be a part of the study. Another important part of informed consent is it is not a one-time deal. If someone basically consents to be in your study and 5 minutes in goes, I'm done, I'm out, I don't want to participate anymore, they have every right to withdraw at any point with no penalty. So if you were giving them something for being in their study, once they consent, if they later decide to withdraw that consent, you would still be required ethically to provide them with whatever that compensation was, whether it was course credit, whether it was money, whether it was some kind of gift card. Also, if your study involved any kind of deception, and some studies require, you can't always tell everyone exactly what a study is about or what's going to happen in a study. And if you've gotten permission to use some form of deception, and we'll talk more about deception in a future lecture, you do need to have a debriefing form that informs them why that deception occurred, why it was important, what the deception was, and again, offer right to service. Any study that's actually using human participation does have to be reviewed by some form of institutional review board or human subjects committee. Here, it's conducted through the Office of Research and Development and Administration, and at other universities, there are other types, but basically, it is usually a panel of at least 3 people. There's usually at least an expert in the field. There's usually someone that's a general, has a general understanding of research methods and the population, and often someone from the community at large. And all of them will review your research and ask, is it ethical? Is it truly an informed consent? Do they have voluntary participation? And is there a reason that you're doing the study? And have you justified if you're doing anything that requires a debriefing or anything that requires right to service?